we're going to carry on looking at the Panasonic NV-MS1. Just can't get enough of it. We'll see if it's possible to get the power supply working properly and not making that screeching noise anymore by replacing some capacitors in it. I'm pretty sure that's what will be the problem with it. They've dried out or leaked over the years. So we'll see if we can get it going better by replacing them, and also we'll solder a bit of wire from wherever that transistor was over to here so we can bypass that damaged track. Presumably there's no other tracks damaged. I don't know, it's a bit weird, but we'll find out. Got power again, so back in the normal recording situation, but we also got new audio setup, new microphone. Hopefully that makes things better. Got one of these now, which is supposed to be very good, and it's positioned up here, so hopefully that means good sound now, maybe, though I might still spend quite a long time adjusting the equalizer and other settings like I've already done today, and now it's too late to do the rest of this video, but I'll carry it on tomorrow, I guess. What we've got is I've got the page from the service manual here, and I've highlighted the capacitors that I think are most likely. So this is the power supply, and I highlighted the capacitors I think most likely needing to be replaced there. So mostly 100 microfarads, 220 microfarads, some little 22, 220, 100, 100, 100, and then down the bottom there 33s, 47s, 22s, 10s. Let's see what I've got in the capacitor collection. I know I've got various bags of random capacitors. They're all 10 microfarads, 63 volts. Then I got this huge bag of these, which are 100 microfarad, 35 volts. So that's going to do us for all the 100 microfarad needs. Problem is they're a bit big though. And I'm pretty sure I've got a whole bag of 220 microfarads as well. Well, the benefit now is I can speak away from the disc and you still hear it. This is a whole bag of really high quality, 105 degrees, Panasonic 220 microfarad 25 volt capacitors. So that's going to do us for all the 220s. Excellent. But these capacitors here, these Nova ones are probably a bit suspect, but anyway, this is mainly just for fun to see if we can get it going, because I suspect we won't be able to fit these new capacitors on the circuit board properly because the diameter will be too much, and yeah, because they're all quite compact capacitors, unfortunately. Let's just get in there and have a look. See, the capacitors in question are these ones down here around that inductor thing. Now maybe we'll get away with it for some of them, perhaps not all of them. Well, anyway, we'll try. We might have to put some of the capacitors on the back side of the board if they don't fit. I'm also going to have to work out where they are, but that's all do I don't know what I'll do. There appears to be, so those two biggest ones there I think are the 220s. There should be 3 of those. Maybe there's that blue one as well, which looks the same size but a different color. And then there's a short one there. The problem is that I guess the footprint of them's those white things. Should we try to get one out now? The problem is it's getting late. That never stopped anybody. Let's get this thing in there and see whether that can, if we'll just get one of these out and just bend these fuse things out of the way. Also, I'm guessing the capacitors have leaked on the board, made a mess of it, so it'll be a bit stinky when these get desoldered because it'll be heating up all that capacitor juice. It's going to moisten the sponge for the soldering iron. Although we're supposed to use that wire wool thing these days, aren't we? We'll probably have to get this desoldering tool in there as well, because We need to unblock these holes. Just thinking about freshening up that solder there. Yeah, it's pretty crusty and dried out. Because the thing is, these capacitors running at high frequency, fairly high frequency, would have been cooking away. Yeah, the board is pretty unhappy about that. Let's see if we can shift that one without melting the stuff around it. Yeah, I think it's out. There's wires going all over it. Oh, it's a really thin board, so yeah, the legs of the capacitors are very short. What have we got? Can't grab it. Okay. So that's what we pulled out. That's a 220 mic 10 volt, 85 degree cap. I guess it's a pretty old school, slow, low frequency switch mode. I don't even know what the designator is of that because there's so many of them around. Pull some of these wires out. Remember to plug all that stuff back in. We'll just pull out the other 220 mics while we're here. I don't know why they're a different size, 10 volt. And when we pulled out, it's also 10 volts. It's just a flatter one. Not really sure why they made it a different size. Doesn't seem to be any reason for that. You have to let me know if the sound is better in this video, although it's going to be hard to compare because the last two videos were done on the phone, which was pretty terrible, and I was holding my fingers on the microphone accidentally for quite a lot of the video without realizing it. Give them the smell. They smell okay, but they are kind of sticky to touch. Oh yeah, and there's heaps of juice on the board as well, so yeah, that's wrecked. Well, yeah, we're going to have to clean up the board a little bit, I think. So that's a 220 mic 10 volt, and the other was a 220 mic 10 volt. Okay, let's pull out this other one, which I think will be the last 220 mic 10 volt. Need some fresh solder in there. I guess we could use some flux. Flux? That's stuff that people pour all over everything these days. It's flux in the solder. Okay. A third 220 mic 10 volt. And it's kind of, you can see there's brown marks. I'll get those wires out of the way. There's brown marks around where those capacitors were, which is probably leaked electrolyte. So this one down here, this blue one, that's 100 microfarads, that's C1007. Okay, so that's the input one. If we look here, so that's up here, 1007, and those other three we've done must be that. 35, yes, that's one of the designators. 16, I guess. There's also some more capacitors over this side. Yeah, they haven't put the designators on the bottom for those. 14 is that one, which is a little tiny one. Is that involved in this? Doesn't appear to be. Would these be somewhere else? Must just be... Oh, and I think somewhere over this side. Oh, that's 120, that's 20. Okay, yeah, so that's that one there. Alright, so there's 3 there. Yeah, if I pull out more wires, then there's more chance of getting some screwed up. Can't pull out those ones there because yeah, they use the same connectors. Let's just pull out more. I wonder if it's this capacitor juice that wrecked that track that goes to the power switch. No, it's not flux, it's that stuff we saw dribbling down into the battery thing on, I think the other camera, one of the other cameras. That's cooking the circuit board. Okay, that one's come out, so that's 100 microfarad. That one doesn't seem to be in such bad shape. And some isopropyl alcohol, we'll give it a bit of a wipe. Goes away easily. Yeah. Let me just hose it in there. Shall we just do those bigger ones, the 100 microfarads and the 220 microfarads? So that's 4 more on that other side to do. And then we'll try it out, see if it works, or whether it's improved anything. I think there's also flux residue still on here from when it was soldered. Oh, there's definitely some in some areas. Alright, let's put in some new 220s and whatever that other one was, 100 microfarad. Just going to try unblock the legs of this using the legs of the new capacitor. Oh, yeah, they're pretty easy to unblock. Alright, and so let's just pull this board off, get that out of the way while we work on this. Alright, so we've got 100 microfarad in that top position. The problem is it's a mess on the side as well. Yeah, because I can't be bothered getting the soldering iron, the desoldering tool set up. Let's just try and do it a dodgy way. There you go, by heating the both legs at the same time and pushing the capacitor in, it just creates itself a path. Yeah, the capacitor's too diametrial. Yeah, well, we already said it, didn't we, that these aren't going to fit properly, and it's just too bad. And now the other one's not unblocking. Yeah, the other one went so smoothly. The other capacitor, that's not playing the game. Well, it made a real mess of that, so that's good. Hopefully it didn't wreck the board too much. Seems to have held up alright. Should have just unblocked the holes and done it properly. Anyway, that's those capacitors. Let's just solder the holes properly. Good to trim the leggies. I can't even see what's going on. Anyway, I just cut the fuse off. No. Great, I'm sure it's heaps better already. That's going to be us for today. And we'll continue this the next day with these other capacitors from this area. And then we'll try it out. We continue. I forgot to explain yesterday the reason for getting that new microphone, other than it supposedly being professional industry standard, is that it's unidirectional, and I hope that that will reduce background noise picked up and allow less reliance on the noise gate. But I think the equalizer still needs more adjustments. Not really sure what it needs to get it clearer sounding, because it sounds different. I don't know, it's missing something, or it has too much or something, I don't know. Anyway, maybe someone will tell me what to do, or I will fiddle around for a long time and work it out. Anyway, we've got the desoldering tool warmed up, and we're going to try and get out the rest of those capacitors, replace them. 4 capacitors over here, and then we'll see if we made any difference. It might be all blocked up again. Shouldn't be blocked up because it hasn't been used for ages. Give it a good reaming with that. And then got to apply some fresh solder. And the tips on the desoldering tool are a bit worn out, but need to try and get some new ones. It doesn't work at all because it's not. It doesn't heat up around the tip properly. Is it sucking at all? I don't know what's going on. Yeah, supposedly is. The gauge shows it is sucking to some degree. And it's doing a worse job than just pulling it out with the soldering iron. I don't know why. I don't understand what's going on here. That's better. It's just not sealing against the board properly. Maybe we got the angle wrong. Okay, here's a capacitor. 220 mic 6.3 volt. Oh, okay, so that's different to what we thought. 220 mic 6.3 volt. Maybe I should be writing these down so that I can... Do I need to do that to put them back in the right place? I don't know. That has juicy stuff all over it, and now it's on my fingers. 100 microfarad 25 volt. Well, let's replace those to start with, and then we'll move on to the other ones. Capacitor was very juicy. Now we gotta somehow remember what one was what. And just clean the board a little bit from all that crud. Okay, so here we got, what we've just done is C10, this one here, 100 microfarad, so we'll put one of those in. It's not going to fit easily. And the other one was 16 here, the 220. I think we need to wait though until we get the other ones out before we can actually solder those in, because they're not going to fit in that area. So let's get the other ones out. These have nicer looking legs. You hear it boiling the capacitor juice. Oh, there's a massive ground plane there. That'll be why that one's having such trouble getting in there. Let's get some more heat in from another soldering iron. That might help. I'm gonna have to pull out those ones that we put in and try again. Tape, there's an insulator. Okay, that top one's out. So that's a very juicy 100 microfarad capacitor, 16 volt. So we've got another 100 microfarad. And then this other one which is still attached to it. Also very juicy, and also another 100 microfarad. Okay, so it's just that one that's 220. All the others are 100. Now we've got to unblock that hole, last hole. Clean it a little bit. Get rid of some of that capacitor juice. So it was only 16, wasn't it? That was the 220. Yes, all the others are 100. So we'll put in new capacitors, trying to make sure the polarity is correct. Oh, that hole's not unblocked, even though it looks like it is from the top side or the other side. And the last one up here. Right, we'll solder these in, and I think then we're ready to try it out. See if this made any improvement. Oh, we got to solder a link for that wire, haven't we? A link for the power switch. Yeah, replace whatever's wrecked in the board there. Alright, got capacitors in. Hopefully we haven't destroyed anything else in the process. And I will, work out where that wire went to get it to power up properly. I'll check that, and then we'll install it, and then hopefully we'll be all good. Right, we're going to try and repair that problem with it not powering up, which is, we found the connection between this transistor up here and the unrigged net was broken for some reason. We've got some wire wrapping wire here, and we'll try cut off a little bit for that. So just strip the end and then work out the length that you need, and then just slide the insulation along from that bit, and then cut it off, and then you have a nice piece of wire with a very small amount stripped off at each end without having to wreck your hands trying to hold this short bit of wire and strip it successfully. But it takes a bit of practice to know how to squeeze the side cutters to not cut into the wire. Yeah, that can easily happen, and then it just gets cut off. So we'll tin the wire first. Good for using the biggest soldering iron tip we can find for this fine work. That's really helpful. And we'll just solder that onto the top there. Good. And pass the wire under that other bodge that they did. And then onto the unrig. Lacking solder there. Okay, probably good to go now. We've got the wire soldered on to the top there, and then the other end over onto that unrig test point. I think that's good. Not touching any other things. Just route that nicely through the other components. Alright, well, let's see if we can turn this thing on and find out if this was successful or not. We've got to plug back a whole bunch of wires, put back this control panel. I unplugged a bunch in here to make it easier to access the area with all the capacitors. Alright, that's all connected up. Now the control panel, which goes around that way, doesn't it? Because that goes in there. Can't even put that away anymore because maybe if we squeeze it really hard. Nah, because the capacitors are too tall, but can't do anything about that. If you want to properly restore it, then you could get hold of some correctly sized capacitors, but yeah, finding those might be tricky. Let's plug it in. And let's see if it turns on. It does, look at that. Turned on. Now we want to see, do we get an output on this? Oh, look at that. It's got a clean picture. That wasn't the case before, was it? It had brown, weird gold brown colored lines all over it. Something like that. It looks fine. And it's not making that noise anymore. So it wasn't, yeah, it was the capacitors. Now we've got to try the moldy tape, haven't we? Maybe a good tape. See if that restored operation. Let's go and find a tape. Been moved and put away. I'll find a tape. It's good. It's got a nice clear picture, which is quite good, with proper color, and it, yeah, let's try the tape. So this is the tape that was in the camera, and there's another tape here that we can try see what's going on. To hold that in, see if it will play it for us. Sort of, it's a bit flickery. Probably needs a good clean. I don't know if it's got auto tracking. Probably not, because yeah, tracking it right over to the edge there. And the picture's become more stable. It's got little bits of stuff on it though. But yeah, more or less working now. So just a power supply change, or a power supply improvement. Let's try the tape that was in it. See what that has, any secrets on it. There's no rewind. Is that jammed? Weird, it plays but it doesn't seem to rewind or fast forward. It doesn't sound too happy, does it? There we go, it's rewinding now. Don't know what the trouble was there. Is it just getting stuck? Maybe this tape has been still for so long it's got a bit sticky. There you go. It's someone's Christmas. Very good. I wonder what the problem with that rewinding is. It seems to be fine now. You see that pulley is moving, which moves an idler gear over, which engages on either the supply or take-up reel. That wasn't moving at all before, so it suggests something is jamming somewhere with those reels. But it seems to be alright now. It is a bit crusty. Perhaps we should try cleaning the heads and the other bits of the mechanism and see if that tidies it up a bit. The thing is, it's probably going to have other capacitors gone bad all over the board, though they shouldn't be as bad as the ones in the switching power supply, because that is exposed to quite a lot of ripple. But I wouldn't be surprised if other capacitors have leaked as well. Yeah, they definitely have. Look at that one right there, because that's oops, let me just snap something off. That wire's pulling so tight. Don't know, was that attached? Anyway, yeah, I can see that capacitor there. It's got juice coming out the bottom of it, so that pretty much guarantees that all the other capacitors are going to be on their way out as well. So there's probably not that much hope for it. Well, not much hope for it unless you replace all of the capacitors. But it's more or less functioning now, which is nice. I can't put it back together because of that. Alright, we'll take the other side off and give it a little bit of a clean, and then see if that improves the picture at all. Now that means we've got to do the rest of the taking apart of this thing. Before we'd only done the minimum to get that side off. This pretty much tells us that it's going to be the same problem with all the other cameras in this series sooner or later, because they all used the same sort of power regulator as we saw. Now we're going to have to pull off all this camera business, which means again we've got to, oh, they put a UV filter on that one. It's got mildew and stuff on it. Wow, a lot of crud on it. And yeah, some sort of mildew stuff starting to grow on there. At least there are some screws under this hand grip as well. Gone all rusty from touching people's hand juice for long periods of time. Corroded from there. Alright, it's open up. And let's get that interesting roller there. I'm gonna get this stuff out of the way. Alright, let's clean this up. Doesn't seem to be... there's bits of sticky, dusty stuff on there. Not too bad, but it could be better. So let's clean it. Give it a rough going over with this to start with. Just to get the worst bits off of it. There's some crud on the capstan. Alright, this thing's a proper clean. Yeah, that thing turns around. Can get to the pulley in there to turn this. Haven't got much like tape flakes stuck on it, but it's a bit dull at the edge. Okay, and finally we'll clean the head and see if that helped at all. Probably didn't do much. Didn't really take much crud out of it. And it's pretty much clean, there's nothing wrong with it. Almost nothing coming off of it. This machine's probably hardly ever been used. Maybe that's the only tape that's ever been in it before. The one that was stuck in it. Someone's treasured family recordings. Stuck in there forever. Never rewatched. Why is there a loop there? Let's try this. Just for fun. And then that's us, I guess. Camera's still good. Still a bit unstable. Push the tracking right to the edge. Comes right. Mostly. I think this tape's just tracked off the edge a bit. Well, the alignment of this machine is different. Yeah, there's those little marks though. Probably not the best tape if its alignment is weird. You know what that does? Helps get everything in the right position. So it's more or less good and working, but as we can see, there are other capacitors there that are definitely on their way out, and yeah, it's going to get, the performance of this will degrade more as the capacitors continue to wear out. And unfortunately you can't do anything about that unless you replace them all, and as we saw, they're not that easy to get out. It's a thin board with very tiny pads on it that don't accept heat that easily. So yeah, it's a bit of a job. And there's heaps of capacitors in there, look at them all. Heaps of little capacitors. Alright, hopefully found that interesting. It's a way to repair your cameras. NV-MS1, M7, M5, M3, M1. They all have a similar power supply, and they're all of the age where the capacitors are going bad. So yeah, if it shows that similar symptoms of lines on the screen, or when you're operating the tape and it's got flickery lines on the video output, then that's a suggestion that these power supply capacitors are going bad. They're either done for or they're almost done for. Just feeling these, are they getting a bit warm? A sign of them doing work? Maybe a little bit. Should we get a thermal camera, and have a look at them? This button has to be held in, which is normally pressed by the flap that's up there that chooses whether you're in record or play mode. That has to be pushed in all the time to get it into play mode. Can I reach for something that... Anyway, one moment. Alright, let's see. Can we see these capacitors being warmer than the others to show that they are doing some work? We won't be able to measure the reflective bit on the top of them because that won't be showing their temperature, that will just be showing them reflecting heat from somewhere else. The warm thing in there, is the IC behind the capacitors. Capacitors themselves, not overly warm. You can see there, so that bit down the back that's showing up white, that's the IC. That's the switching controller. But then you can see the body of the capacitors is pretty warm compared to the environment and compared to my finger, which is somewhere around 31 degrees. So the capacitors are warmer than that, not by a huge amount. And then the capacitors over the other side here, similarly in the 40s, low 40s. If we look at the rest of the board, there's a bit going on in there. We probably should have checked it before we took it apart. We probably would have found those other capacitors were warmer than what these ones are running at. And yeah, you can definitely see they're doing some work, which is why those are the ones that go bad first, especially if they're low quality capacitors or low temperature rating, like because they were 85 degree capacitors. So they're being pushed a bit, and because of the ripple current flowing in them, it heats them up. Because of the impedance of the capacitor, produces some heat, warms up, dries out the electrolyte. Perhaps just for fun we'll try that mold tape that we found in one of those other cameras. I can't remember if we ever got that playing to see was there anything on it. Might as well just give it a go here. Or was it that we found it looks like a completely blank tape? Seems to be the case, doesn't it? Should we rewind it to the start? I think it might have been someone's brand new tape. Nothing. Oh, it got stuck. Brand new tape, nothing on it. Yeah, that's a shame. Doesn't want to rewind anymore. Fast forward works. Yeah, it gives up real fast, doesn't it? There we go. I don't know. I don't think we can rewind it further than that. And the take-up's stuck. Yeah, I guess it's not a very good tape, is it? Don't play tapes that are covered in mold. I don't think there's anything on this one. Well, the bits that we looked at, it's not going to come out now because it won't let it rewind. Yeah, we wrecked that now. Alright, maybe we have to eject it manually. Because, yeah, that's fully... I don't know, there you go. So I wonder what's gone stiff in this tape. So we'll just take it apart and look at it. It's going to get thrown out anyway because we don't want a tape that's full of mold. It's only going to destroy machines that it gets put in. See the break there? Oh, that's wrapped around a little bit. Oh, it's probably because it's turning in the wrong direction. Okay, there doesn't seem to be anything functionally wrong with it. Oh, I see. It's not... Well, you can see it's been stressed at the edge there a bit. But in general, it seems to be alright. You see, the tape comes off pretty easily. It's not stuck to itself. Okay, now it's stuck to itself. Yeah. So that would be providing a little bit of extra resistance for it to unwind. So yeah, the tape's wrecked. Don't put moldy wrecked tapes in your machines because you'll end up ruining them. Yeah, it's pretty stuck. Should probably stop playing with that and just throw it out because it's not good to be exposed to mold. Great, there you go. That's the second part, final part in the series. Yep, that's it. Final. It's never it, is it? That's probably it in the series of investigating National and Panasonic NV-M series video cameras. M1, 3, 5, 7 and M40, and then this MS1 NV-MS1, which, yeah, they've all got bad capacitors in them. So good luck swapping out capacitors in your cameras. And next time we'll take a look at some other video cameras. Got a whole bunch of them stacked up over there. DVC Pro. So we'll have a poke around with those.